So in this video we want to look at another way to calculate the equation of a line called the point-slope form of a line. But before we get to that, I just want to review our first method of determining the equation of a line, and that's called the slope-intercept form. Slope y-intercept form, which is y equals mx plus b. Remember that x and y are all the points on the curve. M is the slope, the rate of change, which for a line is constant, and b is the y-intercept. So if we know m and b, we have the equation of the line. So let me just review this concept with the example below. We have an equation of a line that has a slope of 2 and it passes through the point 1, 5. So there's 1 point, and our slope is 2, which is 2 over 1. Could also be negative 2 over negative 1. So to get a second point, I can go up to right 1, or I could go down to left 1, which happens to land me directly on the y-intercept, you'll notice. How convenient is that? And there's our line. Remember, all the points, any point is xy. So when we're done with our equation, any point on the line that we substitute in for x and y should satisfy the equation. So to get the equation specifically, we need the slope and the y-intercept. We have the slope, so we put the 2 into its position. And if we know the y-intercept, we plug the y-intercept in directly. Now we do know the y-intercept, like I said, because of this particular example. We know it's 3. In most cases, you won't know the y-intercept directly, and what you'll have to do is you'll have to use some other given point. So let's just assume for a moment we don't know the y-intercept, and let's take a point on the graph. This is one value of x and y that satisfies this equation. If I plug in for x and y, we can algebraically calculate the y-intercept, which is 3, which, as I said, is what we can visually see on the graph, and therefore the equation of a line is 2x plus 3. Alright, now I'm going to demonstrate another way to calculate the equation of a line using something we call the point-slope form. And so for this, what I need is a point on the graph, which I have. I have one specific point that I know. I know the slope is 2. And remember what I said, all of the other points on the graph are called xy. X and y are related by the equation we're trying to find. So if we think about this, what do we know is true between this specific point and all points? Well, with a line we know that the slope is constant at 2. So if we take any 2 points, a general point and a specific point, what I'm going to do is I'm going to do the slope formula between these 2 points, between this general point and this specific point. So if we do the slope formula, y minus y over x minus 1, so the slope between any point and this specific point is, we know it's going to be 2. And what we've come up with here is a relationship between x and y. We have the beginnings of our equation. Well, we have our equation. We're just going to reorganize it. So we're going to multiply both sides by x minus 1 to clear the fractions. And actually, that's the way we're going to leave our equation, just like that. Now that looks a little unusual because we're used to always isolating y. You don't actually have to do that with point-slope form. This is called the point-slope form of a line. And just to show you that it is in fact the same as the equation we got in via the first way we did this, let me just simplify this. Now I'm saying you don't have to simplify this, but if you did, add 5 to both sides, we get what we got when we did this with the slope-intercept form of a line. So just to review one last time what we've done. What we had is we had a line, and we had a specific point on that line, which I'm going to label as x1, y1. And we took a general point on the line, which I'm just going to label as x comma y. Okay, so keeping in mind this can be anywhere on the line. And the slope of the line is m. So therefore, if we take the slope between any 2 points on a line, y minus y1 over x minus x1, we will get that constant slope. And if we move this over to the other side by multiplying both sides by x times x minus 1, we get our equation looking like this. And this is what we call the point slope form of a line. And this form of a line makes it very convenient to calculate the equation of a line. For example, let's suppose we had a line passing through negative 3, 7 with a slope of 2/3. Alright, now I could sketch this out, and why don't I just go ahead and do that? Negative 3, 7, somewhere here. I got a slope of 2/3, which means we rise 2 and we run 3, so the line looks something like that. Here's my point, negative 3, 7, and x comma y is any point anywhere on the line. So since I have a point on the line and I have the slope, I can use my point slope form of a line. So I'll just write that out. And x1 and y1 are the specific points that we know. The slope we know as well, so we can substitute that in. So we're going to go y minus 7 equals our slope of 2/3, x minus negative 3, which simplifies to x plus 3. And that's the equation of our line. We could simplify it to isolate y, but we don't have to. Alright, another question. This time we have 2 points, negative 3, 7, and 0, negative 2. So our line looks something like this. This time we know 2 specific points on the line. And we are going to use point slope form to calculate the equation of the line. Alright, to use point slope form we need to know 1 specific point on the graph. We actually know 2. So we have more than we need. We do need the slope. So I'm going to need to calculate the slope between these 2 points. So I'm going to use my slope formula. So 7 minus negative 2 over negative 3 minus 0 would be 7 plus 2, 9 over negative 3. So the slope of the line is negative 3. It's a negative slope, the line is falling at a rate of 3y drops for 1 unit of x. So therefore, my equation of my line is equal to, I can plug the slope into its position. Now in terms of the specific point I'm going to use, I can use either one. So if I use this point, I'm going to get y minus 7 equals negative 3, x minus negative 3, which is x plus 3. Now you might wonder, what if I had used this point for my point slope form? Would I have gotten a different line? Okay, well let's take a look. So we would have had y minus negative 2, y plus 2, would have been our slope, which was negative 3, x minus 0. Our 2 equations look different. But if we simplify them, now again, I'm saying you don't have to simplify them. You could leave the equation of a line in either of these forms. They're actually the same line once you reduce them. So let's do this one first. Add 7 to both sides. I get the equation reducing to that. If I do the same thing over here, this is just negative 3x. Bring the 2 over. I get the same thing. And actually, if I now think about it, I'll notice that one of the points I had was the y-intercept, wasn't it? So I could actually have used y equals mx plus b to build the equation. I still would have had to have calculated the slope, but I had the y-intercept, so I could have put it into its position, and I would have therefore gotten the equation a different way. So we now know two ways to get the equation of a line. Y equals mx plus b and point slope form.